Energy, a term used frequently in science, can be understood as the capability to accomplish tasks or perform work. It exhibits itself in numerous forms, including chemical, nuclear, and electromagnetic energy, among others. One interesting thing about energy is its ability to metamorphose from one form to another. This complex transformation process is a critical part of how things function in the world around us. Consider the example of kinetic energy. This is the kind of energy that an object possesses when it is in motion. Imagine a ball that is rolling down a slope. It is bustling with kinetic energy. The velocity and mass of an object are directly proportional to the amount of kinetic energy it possesses. This is why a bowling ball rolling at the same speed as a tennis ball will possess more kinetic energy. It simply has more mass. However, if the tennis ball is moving at a higher speed than the bowling ball, it may hold equivalent or even more kinetic energy due to its velocity. However, not all forms of energy are as dynamic as kinetic energy. Let's take a look at potential energy, the energy held by an object due to its position. For instance, a ball situated at the peak of a hill has energy, even though it is stationary. This energy, stored and ready to be utilized, is termed potential energy. How much potential energy an object has is determined by its placement or position. Gravitational potential energy in particular is a form of potential energy that arises due to the height of the object from the ground level. Thus, every object that is elevated above the ground possesses gravitational potential energy. You, for instance, would have more potential energy if you were standing on a high diving board compared to a lower one. As soon as you jump, your potential energy swiftly transitions into kinetic energy since you are now in motion. A swinging pendulum provides a clear visualization of how gravitational potential energy continuously alternates with kinetic energy. In scientific terms, work refers to the act of applying force to move an object over a certain distance. If you lift a stack of books off a table, you're doing work since you're moving them over a distance. But if you're simply holding the books without moving, even though you're applying force, you're not technically doing work since the force is not acting over a distance. The amount of work done can be calculated using the formula work equals force push or pull multiplied by the distance. Force is quantified in a metric unit named newtons, N. A single newton is equivalent to the force necessary to alter the speed of a 1 kilogram object by 1 meter per second each second. Using this formula, let's calculate the amount of work required to shift a box 10 meters. If the force needed is 40 newtons and the distance is 10 meters, the work equals 400 joules. A joule, in basic terms, is the work done by a force of 1 newton over a distance of 1 meter. Suppose you decide to place the box in a wagon. How would this impact the values in the formula? Would the work required to move the box over the same distance be different now? Indeed, it would. The wheels on the wagon would help to decrease the friction, thereby reducing the force necessary to move the box. As a result, less work would be needed to pull the box in the wagon. It's essential to note that friction is a force that resists the relative motion of one surface past another. Hence, a baseball rolling over a rough surface, like sand, would face more friction compared to when it rolls on a smooth surface, like a wooden floor.